2 lecture video, we're going to talk about distribution of the sample proportion, which is fairly similar to what we did last time, which was distribution of the sample proportion, sample mean in section 8.1. So the population proportion P is the proportion of the population with a certain characteristic X. So this is X divided by capital N. Similarly, suppose that a random sample of size lowercase n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion, which we write with P with a little caret on top of it, is read P hat, is given by P hat equals X divided by lowercase n. So it's simply the number of people in the population that have that characteristic divided by the number of people in the population. Another way to think about this is it's the percentage of people that have the characteristic. So the sampling distribution of p hat will follow a approximately normal if the following is true: n times p times 1 minus p is greater than or equal to 10. Now the nice thing about that is if it's normal, we can use our normal distributions to find probabilities. And that's what we're going to do in this section. The mean of the sample addition p hat, mu sub p hat, is just whatever p is. And the standard deviation is the square root of p times 1 minus p divided by n. So let's take a look at a problem for this. So a nationwide study indicated that 80% of college students with cell phones send and receive text messages with their phones. A simple random sample of 200 college students with cell phones is obtained. First of all, describe the sampling distribution. So the first thing we want to do to do that is decide if it's normal. So we take n times p times 1 minus p. In this case, the sample size is 200. The population proportion is 0.8. And because it's 80%, right, that's 0.8 as a decimal. And then 1 minus that. And when we do that multiplication, we get 32, which is greater than or equal to 10. So this is approximately normal. So now, to further describe it, we can state the mean and standard deviation. So the mean is simply the population proportion P, which in this case is 0.8, and the standard deviation of P hat is the square root of P times 1 minus P over 200. So in this case, that would be the square root of 0.8 times 0.2 over 200. So that should be 0.028. So now that we know it's approximately normal, we can look at its normal distribution. So let's go ahead and do that on the calculator. So on the calculator, I do the same thing we did in the last section. Distribution plot, normal distribution, put in my mean, which is 0.8, and my standard deviation. Now, I like to type in the standard deviation so I don't get any rounding errors. So I'm just going to write it out as 0.8 times 0.2, the square root of 0.8 times 0.2 divided by 200. Okay? And then we're going to zoom in on that. And we get our normal distribution that looks like this. Okay, so now that we have our normal distribution, we can do some probabilities on it. So it says, what is the probability that 154 or fewer college students in the sample send and receive text messages with their cell phones? So that would be the probability that X is less than or equal to 154. So you could try and go in to your calculator here and just put in X is less than or equal to 154. And if you do that, it's going to tell you the probability is 1. And that's because if you look along the bottom of this, the graph here, notice that my X values go from 0.7 to 0.9. So everything in this graph is a proportion. It is the number of things in the number of people with the characteristic divided by the sample size. So they're all between 0 and 1. So I cannot put in whole numbers. So when I go to do this probability, what I actually want to do is I don't want to do what is the probability that I get 154 or fewer people with that characteristic, I want to do the probability that the proportion in the sample is less than or equal to a proportion, 154 out of 200. So if we go put that in the calculator, 154 divided by 200, then we get a reasonable answer. Okay. Now you can't actually see it on the graph here, but it's 0.1444. Okay. And then it asks, would this be unusual? And the answer to that is no, it would not be unusual because 0.1444 is not less than or equal to 5%. So then we can do the probability that x is greater than or equal to 172. So that would be the probability that p hat is greater than or equal to 172 out of 200. So we go and we can put that into our calculator. So 172 divided by 200. And that's 0.0169. And that would be unusual because, so that is unusual because 0.0169 is less than or equal to 0.05, 5%. Our answer is 1.7% approximately. Okay, so that's the idea. So why don't you guys go ahead and flip over to this next page and try these, pause the video for a moment and try these two problems on your own, and then we'll go through them together. Okay, so now that you've given these a try, we can go ahead and do them. So we first want to describe the sampling distribution. So we first do n times p times 1 minus p. So that's 100 times 0.82 times 1 minus 0.82, which is 14.76. So that's greater than or equal to 10. So this is approximately normal. Okay. And then we can ask, and then since it's approximately normal or just in general, we can say what the mean is. So the mean is p, so that's 0.82. And the standard deviation is the square root of 0.82 times 0.18 over 100. Okay, and 0.18 is simply what 1 minus 0.82 is. And so now we can put that into our calculator to get our new graph. So 0.82 okay, and we can zoom in on that one. And so there's our new graph for this problem. And so then we can answer the problems that they ask here. So they ask, what is the probability that at least 85 Americans, so that's the probability that x is greater than or equal to 85, which is the probability that p hat is greater than or equal to 85 over 100. And then the second one says 75 or fewer, so that would be the probability that x is less than or equal to 75, which is the probability that p hat is less than or equal to 75 over 100. Okay, and then we can put those into our calculator and get the probabilities. So the first one, okay, so the first one was greater than or equal to 85, so that would be divided by 100, so that would be 0.85. And so the probability of that is 0.2174. And then the second one is less than or equal to 75 over 100. So that would be less than or equal to 0.75. And that's 0.340342. So the probability that we would get at least 85 is not unusual, but the probability that we would have 75 or fewer is unusual. Okay, so that's the idea. So then we can do the same thing for the second one. So we take 500 n times p times 1 minus p. So that's 500 times 0.26 times 0.74. And that's 96.2. So that is greater than or equal to 100. To 10. So because that's greater than or equal to 10, we know this is approximately normal with a mean of 0.26 and a standard deviation of the square root of 0.26 times 0.74 over 500. Okay, so then we go into our calculator here, and I can put in my new values. So 0.26, 0.74, and 500. Okay, and now notice this isn't showing up in my current view because I'm over here around the 0.8. So I can hit my magnifying glass and come over to this graph. And there's my new normal distribution. And then it says, what is the probability that is less than 24% have no credit cards? So notice in this case, the question is written as a proportion. So it's asking, what is the probability that the proportion is less than 24%, is less than 0.24. So in this case, I don't need to adjust it. So we go in here and I can just get rid of this and put in 0.24. Yeah, so it's the probability of less than 0.24. So x is less than or equal to 0.24, and that's 0.1540 if we round to 4 decimal places. Okay, and would it be unusual for if a random sample of 500 adults results in 150 now having cell phones? So the question for that to be unusual we need to know what is the probability of 150 out of 500 or more extreme. And so the question is, which direction is more extreme? So what we do is we take 150 divided by 500, and we get 0.3. So this is 0.3. And so since 0.3 is greater than our mean, we want to go greater than that. We want to be more extreme than that. So we want to go away from the mean. So we want p hat to be greater than or equal to 0.3. So we can do that probability. So we want x to be bigger than 0.3. And the probability of that is 0.0207. And so yes, it would be unusual because that's less than 5%. Okay? So that's the idea of how we can use this idea to find probabilities of proportions. Now, let's try some other similar problems with these. So a report released in May 2005 by First Data Corp indicated that 43% of adults have received a phishing contact, a bogus email that replicates an authentic site for the purpose of stealing passwords. A random sample of 800 adults results in 328 indicating that they have received a phishing contact. Explain why this is not necessarily evidence that the proportion of adults who have received a phishing contact has decreased. Okay, so what we basically want to know is well, what is the probability of this sample occurring given that this is the population mean? So to do that, we can simply make our normal distribution here. So this was 0.43. Let me actually check that. Yeah, 0.43 is our mean. And so our standard deviation is 0.43 times 1 minus 0.43, which is 0.57, divided by 800, because that's our new sample size. And then we can graph this. So here's the graph. And so the question is this evidence that it's decreased? So the question is the probability that p hat is less than or equal to 328 out of 800 unusual? Okay, so we can put that in and see what we get. So it's decreased, which is why I put x is less than or equal to. And we can see that the probability of that is 0.1266. And the reason this is not necessarily evidence that the proportion of adults who have received a phishing contact has decreased is because this result is not unusual. It's not less than 5%, given that mu sub p hat equals 0.43. So assuming that the 43% is accurate, the result we got would not be unusual, right? There's a 12% chance that I would get a sample like that or more extreme, so that's not an unusual result. So therefore, that does not suggest it has decreased. Now, if we had gotten like 0.0126, a 1% chance of getting that sample, that would have been evidence that it probably has decreased since May of 2005. So that's one type of problem we can do with this. So just using probabilities to decide if a sample is unusual. And then the other part we can look at here is looking at how big of a sample do we need to answer the questions we have. So a researcher studying public opinion of proposed Social Security changes obtains a simple random sample of 50 adult Americans and asks them whether or not they support the proposed changes. To say the distribution of p hat, the sample proportion of adults who responded yes, is approximately normal, how many more adult Americans does the researcher need to sample if 10% of all Americans support the changes? So the key is to remember that this formula, n times p times 1 minus p, has to be greater than or equal to 10 in order for us to say that the data is approximately normal. So what we can do is we can substitute in our p, which in this case is 0.1, and solve for n. Okay, so that's n times 0.1 times 0.9 is greater than or equal to 10. So this, we divide both sides by 0.1 times 0.9. And so we get n is greater than or equal to 111.1. And so if our for our guy for this to work, for it to be greater than or equal to 10, and because I cannot use, first of all, I have to use whole numbers, right? Because I'm sampling people. So I need to round this off, but can I round it down to 111? Well, no, because 111 is not greater than or equal to 111.1. So I picked the first whole number that fits this inequality, which means he needs 112. And if he already has 50, that means he needs 62 more. Okay. And then the second problem here would be the same idea, except instead, if we assume 20% of all Americans, all I would change is my p. So this would be n times 0.2 times 0.8 is greater than or equal to 10. So n would be greater than or equal to 10 divided by 0.2 times 0.8. So n would be greater than or equal to 62.5. And so once again, we pick the smallest whole number greater than that, which is 63, minus the 50 he already has, and you get that he needs 13 more. Okay. So that's the idea. So go ahead and flip over to the next page, page 10. Pause the video for a moment and try these two problems here. And once you're done trying them, you can restart the video and we'll go through them together. Okay, so let's go and through these together. So according to a study conducted by the Gallup organization, the proportion of Americans who were afraid to fly in 2006 was 0.10. A random sample of 1,100 Americans results in 121 indicating that they are afraid to fly. Explain why this is not necessarily evidence that the proportions of Americans who are afraid to fly has increased. So we can start by drawing our normal distribution, right? So we've got an n, a p of 0.1 and an n of 1,100. So stat, distributions and plots, normal distribution. 0.1 is our mean, and our standard deviation is the square root of 0.1 times 1 minus 0.1, which is 0.9, over our sample size, which is 1,100. Okay, and then we can zoom in on that. Okay, so in this case, we want to look at the probability of this occurring and see if that shows that we have increased the number of people who are afraid to fly. So I want to find the probability that P at is greater than or equal to 121 over 1,100, because we're looking at increased, so that's why I'm going to do greater than or equal to. So we'll do P at that x is bigger than 121 divided by 1,100. And the result is 0.1345. And since this is not an unusual result, it does not show that this has increased. If the percentage of people that are afraid to fly is still 0.1, we have a 13% chance of getting this result, which is not unusual. So that's why it's not evidence that more people are afraid to fly. And then the second problem here, we have 100 people already for our sample, but we need to get some more. So in order to be approximately normal, we need to have n times p times 1 minus p greater than or equal to 10. So we solve this, so it's n times 0.9 times 0.1, which is greater than or equal to 10. Divide by 0.9 times 0.1. And you get n is greater than or equal to 111.1. In this case, so that means you need 112. This researcher already has 100 people, so we need 12 more. And if we change the percentage to 0.95%, then this is n times 0.95 times 1 minus 0.95 has to be greater than or equal to 10, so that's n times 0.95 times 0.05 is greater than or equal to 10. Divide, and you get n is greater than or equal to 10 over 0.95 times 0.05. So n is greater than or equal to 210.5. So that means they need 211. They already have 100. So that's 111 more. Okay. So that's it for section 8.2 and also for our chapter 8 videos. So make sure you're doing the homework assignments that are due on Sunday, along with a quiz for chapter 8. If you have any questions, feel free to email me, text me, or send me, call me on the phone. My email and phone are in the emails I've been sending you. That's it for today.